Hi guys, today we're going to talk about how to find the arc length of a circle and the area of a sector. So the arc length of a circle is a fraction of the circle's circumference. So it's kind of hard to understand exactly what that means, but I want you to think about it in terms of, imagine if you wrapped a piece of string maybe around a can, and you just wanted to know like what 1/4 of that measurement was, maybe in terms of a fraction in a linear measurement like inches or centimeters or something like that, then what you're talking about is saying, okay, well, I'm going to wrap this string around the can and I just want to figure out what 1/4 of the distance around that is. And then you might unwrap it and just measure that distance in a straight line a little bit. So you just have to imagine that you are thinking about taking a portion of the circle and kind of tracing it a little bit with a string and then straightening it out a little bit, and measuring it maybe against a ruler. So there's a formula for finding arc length. Because arc length is a fraction of the circle's circumference, in fact the circumference, we're going to use that in the formula. Okay, and the formula for arc length, and I'm going to use AL for arc length. Arc length of a circle is equal to the measure of the arc in degrees divided by 360 degrees times 2 pi r. Okay, remember that 2 pi r is circumference, so think about this as a fraction of the circumference. A fraction of, in math means multiply, so a fraction of the circumference of a circle. So for this circle that you see to the left, it would look like 60 over 360 times 2 times pi times 10, and then we would simplify that whole thing. I'm not going to do it in that particular problem, because we're going to work that in the next couple of problems right here. Okay, so we're going to find the indicated arc length, and in problem A, we're going to find the length of arc XY. So let's talk about where is that arc right here. There it is. So let's write down the formula for arc length. Arc length is equal to the measure of the arc in degrees divided by 360 degrees for the whole circle times 2 pi r. So the measure of this arc, remember that the measure of an arc is equal to the measure of the central angle that intercepts that arc. So if the angle here is 90 degrees, then that arc must also measure 90 degrees. So we're going to say 90 over 360 times 2 pi, and if the diameter is given as 16, that means r equals 8, right? Then we're going to reduce everything. So I'm going to cancel, and 9 goes into 36, and I get 1/4. And now we have 1/4 of 16 pi, if you will. And recall, like, I know some of us have struggles with reducing fractions, but you can think about that 16 pi as over 1, and then reduce the 4 and the 16 to get a total of 4 pi inches in arc length. That's an exact value, and of course, if you're told to approximate, then you should approximate accordingly. Now let's take a look at the next problem over here, B. We're going to find the length, not the measure of an arc, but the length of arc XPY, which is here. Let's start at X, work around the circle through P until we get to Y, which is a totally different arc. Remember, that's a major arc, so let's think about what we're going to do there. Again, we're still going to use arc length is equal to measure of the arc divided by 360 times 2 pi r. We know the radius is 15, but we don't know the measure of arc xpy. That's the unknown quantity that we're looking for. So what we can do is say, okay, well, if this minor arc xy is 120, and these two arcs make up the whole entire circle, then 360 minus 120 is 240, and that's the measure of arc xpy. And our radius is 15, and then we're going to cancel. We know we can cancel out the zeros and divide by 12 and get 2, divide by 12 and get 3, right? Okay, so now we have our arc length is equal to 2/3 of 30 pi, and then you can again just reduce the 3 with the 30 and get a 10 there, and then that makes it pretty easy to calculate your arc length as 20 pi centimeters. Remember that arc length is a fraction of the circumference, and circumference is kind of like relatable to perimeter. So arc length and circumference and perimeter are all measured in linear units. All right, so for the next problem, we're just going to remind ourselves a little bit about area of a circle. I know you've just done it pretty recently, but sometimes we forget because we're going to start talking about the area of a sector of a circle, and we're not going to, we want to make sure we recall that. So we want to know how much more pizza is in a 12-inch diameter pizza than a 10-inch, which means if we want to know how much more, we have to do the area of the large pizza minus the area of the small pizza. So remember pi r squared. Let's call this r sub 1 equals 6 and r sub 2 equals 5 for the radius there since we're given the diameter. So we'll say r sub 1 minus pi times r sub 2. Why am I writing a sub 1 and a sub 2? Just to distinguish between the two different radii of those pizzas. That's the only reason why. So pi times 6 squared minus pi times 5 squared. So 36 pi minus 25 pi gives you 11 pi. Doesn't make a lot of sense in the form of this particular problem because really we don't talk about how much more pizza or quantity of pizza in terms of 11 pi square inches, right? We don't say that. That is an exact value if you had to do an exact value. It certainly makes more sense to, in this case, find an approximate value. So approximately 34.6 square inches more pizza in the 12-inch diameter. That's kind of a lot, right? Maybe. I'm sure you can handle it. Okay, let's start talking about area of a sector. A sector is a part of a circle that's bounded by two radii and the endpoints of the radii and an arc of a circle. So a sector is bounded by a radius, two radii, and the endpoints of these arcs, the endpoints of those radii and that arc, right? So definitely a good idea to think about the area of a sector as something like a slice of pizza, right? That it's pretty flat pizza at that, all right? So if the area is a fractional part of the area of the circle, then the formula for area of a sector must be the measure of the arc divided by 360, a fractional portion, times the area of the circle pi r squared. Kind of makes sense. It's a fraction of the area of a circle, right? Okay. All right, so we're going to find the area of the sector that we see shaded in yellow. So area of a sector is equal to measure of the arc over 360 times the area of a circle, which is pi r squared. So we have 72 over 360 times pi times 20 squared. I'm pretty sure that 72 goes into 360 5 times, but we'll double check. That's 1, that's 5. Okay. So we have 1/5 pi times 400. And again, you can cancel the 5 with the 400. You know that 5 goes into 48 times and you have an extra 0. So it should be 80 pi centimeters squared. Remember now we're talking about area, so we have square units, right? All right. Let's try one more, a little bit different. We want to find the diameter of a circle that contains a sector with an area of 25 pi over 9 meters squared, and it's bounded by a 20-degree arc. So again, for some of us, it's a good idea to make a visual, right? And we're going to talk about a 20-degree arc. So we're just going to make that up right there. And our sector, our shaded sector, might look something like this piece, okay? And we have a 20-degree arc right here. This will be the center of our circle. And we want to know what's the diameter, right? Okay, so obviously if we have a sector with a given area, then we need the formula for area of a sector in order to solve this, right? So we need measure of the arc over 360 times pi r squared. The area of the sector is what's known, so I'm going to put that value, 25 pi over 9, in place of the area because I know that information. We already know the measure of the arc is 20 over 360 for the whole circle times pi. We don't know what the radius is, so that's an unknown quantity, right? So we'll leave that right there. All right, so let's reduce what we can reduce. 25 and 9 don't reduce, but this should reduce to 1/18. So now we're looking at 25 pi over 9 equals 1/18 pi r squared. Now we want to get rid of that 18, or that 1/18, so you can multiply both sides by 18 to cancel, right? And then you can also cancel this 9 with this 18 and get a 2, which means we'd get 50 pi equals pi r squared. Let's go ahead and divide both sides by pi, make our work a little bit lighter. And then we have 50 equals r squared. Take the square root of both sides to find the value of the radius, so that then we can get the diameter, right? So the radius is going to be 5 square root of 2. Don't forget how to simplify your radical expressions, which means the diameter is going to be equal to 10 square root of 2 meters, because remember the diameter is twice as long as the radius. Got it? And that's it.